Good morning. I'm Jasper. I'm no stranger to the CAPE-OPEN community. I will be presenting, let's say, the COBIA progress report this morning, and I'm actually very happy to do so because we made a lot of progress. And actually, when I was preparing this presentation, I had people review it, and the one remark I got afterwards is, "You're missing the why. Why should people be using COBIA? Why do you make a middleware if COM exists?" So Carl already mentioned that CO-Lan is 25 years old. 20 years ago, which stopped maybe 15 years ago, the thing to do after the CAPE-OPEN conference was the Geek conference. We took out our laptops and we sat at the table with each other and we made our software talk to each other just to see if it works. So we're 15 years past interoperability, which means that we had already accomplished CAPE-OPEN interoperability with COM, but that is all on Windows, and CAPE-OPEN is an open standard specification, and open to me means you shouldn't tie yourself into any particular commercial platform such as Microsoft Windows. So being able to run on Linux and macOS for me personally is a very strong incentive to not tie into one particular middleware. So that is maybe a bit of an idealistic point of view. But also a practical one. I want to run on Linux. I want to go into the cloud. I want to, all the people that say, I've got a MacBook, how do you run it? Well, you have to install Wine and whatnot. I want to go there. We also made, of course, a bit of changes to the infrastructure of how to call the interfaces. Just to be clear, COBIA is a middleware. It doesn't define what the interfaces look like. It just defines how to use them. It's a binary interoperability standard. So as opposed to COM, all the arguments in COBIA are strong typed, which makes it much easier to program against because you don't have to type check the argument that comes in. And it is also less error prone because the argument can simply not be wrongly typed. It won't compile if that would be the case. And we changed the memory ownership model in COM. The way it was set up is that if you return a calculation result from a routine, you have to allocate the memory for it before you return it. And in COBIA, we said, no, it is the caller that actually owns the memory. We pass an interface in, and you write to that memory location using an interface to the data. And that also makes it easier to program because one side of the caller-callee relationship owns all the memory. There's no more errors on understanding who owns the memory, who needs to release the memory, because it's all in the same place. And that also makes it more efficient, because if it's the caller that owns all the memory, then you can much easier recycle the memory and use it on the next call, which is much more difficult to do if the callee, the one that's getting called, is allocating the memory every time. So that's why we do it. We want a middleware that is not dependent on Windows. We want a middleware that is easier to program in because COM development was seen as a big hurdle in CAPE-OPEN development. And we want no errors to appear at runtime. You have software from two companies that interact, and when there's an error somewhere, go figure out, is it company A, company B? It's a blaming game. Before you have it sorted out, you're half a year down the road. Better to prevent the errors altogether, right? So that's the big picture on the why. So I'm going to present today the progress report on COBIA. COBIA has a bunch of development phases that we're going through. We're currently in phase 3. I will present on that. I will present on the threading models, which I've presented on last year already, but I will run a quick reminder. I'm going to sketch the big picture on where I want to go from defining the types and using them in an application, and also how COM fits into that. I want to touch upon marshalling of custom types. Custom types are the types that are not defined by the CAPE-OPEN standard. And then again, when I ran this presentation by somebody, he said, why would we be using custom types? Well, for example, the testing suite that Malcolm will present later on is something that you can program from the outside. You can run it as a program that we will deliver, but you can also run it from your own program. And the way to do that is the testing suite exposes a bunch of interfaces on how to talk to it. And these interfaces are COBIA interfaces, and as they're not part of the CAPE-OPEN standard itself, they're custom interfaces. You want to be able to marshal them, to access them from any language. So that is where custom interfaces come in, any interfaces that are not directly defined by CAPE-OPEN. Then we'll talk about a little bit, very briefly about language bindings, platform transport, logging, and I will end with some closing remarks. So we started thinking of an object model would be nice back in 2011. Then in 2016, we actually started implementing COBIA. It took 5 years for that idea to see through. And the first phase was a proof of concept phase. It was just a very small subset of the interface specification running only in process, only in C on Windows. And the only purpose of that really was to convince the management board that it can be done. It can be done. So in 2017, we started programming phase 2, and phase 2 was essentially get the full functionality to work, but limited to Windows, limited to C++, limited to in process, no marshalling. And that was first released in 2017, when it was also taken into production in a number of production softwares. So we have been up and running ever since, but we're now moving to phase 3, and phase 3 essentially is the whole thing. We have marshalling, we have language bindings, we have remoting, and we have logging. And when I say marshalling, it sounds like a very small item, but marshalling actually requires a whole lot of functionality to be there. If you have two pieces of software that talk to each other, they need to play according to the same rules. They need to play according to the same threading rules. Both of them need to be aware of each other's threading restrictions in particular. When we want to interoperate with COM, we also, of course, need to deal with the binary the binary standard that COM talks, and its threading models, which are different from the COBIA threading models. You need to have consistent typing. Consistent typing, I think, is actually one of the big improvements we made when we went from COM to COBIA. In COM, you have like 4 different types of integer. In COBIA, we have only one. It's a 32-bit signed integer. So we have a much smaller data set in COBIA. And if we want to talk to COM, we must make sure that the COM interfaces also have this particular integer that we interact with. We have to deal with custom interfaces, as explained a moment ago. We have seen in the marshalling presentation last year that a lot of the marshalling is actually done by proxy objects that do a lot of the work. So when, for example, a COM PME wants to talk to a COBIA object, there's a marshaller in between. The COM PME then talks to a client-side object that resembles a COM object. It receives an incoming call, it serializes the argument of that incoming call into something that can be understood by the other side, which is then the server-side proxy, which resembles the server side, which actually makes the outgoing call onto the object that is being talked to. These proxy objects are, of course, just a bit of code, so we can either pre-compile them from type information. But if we don't have pre-compiled proxies because we didn't know the type information at compilation time, we can also do it on the fly when the process is running. All of this, of course, requires type information. The types needs to go somewhere. So we register the types in the COBIA registry. And that in turn requires an API to be able to access all this type information. And we have such an API, and it's currently being made public. So if we say marshalling, we're actually talking a whole bunch of work that we need to do to get to that point. So I'm going to elaborate on some of that and how the pieces all fit together and where we are with that. So this is a bit of a reminder on something I presented 2 years ago, I think, on threading. CAPE-OPEN objects have a state. What we see here is a sequence diagram of the PME on the left, talking to the property package in the middle, and there is a material object involved. So the PME sets a material object on the property package. Then the PME puts the calculation conditions on the material. Then it asks the property package to do a calculation, for example, a phase equilibrium calculation. The property package talks to the material object to get the calculation conditions. Then internally it does the flash calculation. Then it sets the results on the material object, and then the control returns to the PME that continues to pull the results off of the material object. So there's a sequence of calls going on there, and it doesn't make sense, of course, if another thread 2, is talking to the same property package, and halfway during that sequence says, I'm going to change the material object on you. What happens now is that the property package is sending its output to the wrong material object, the material object that thread 2 is using, and thread 1 never got its result. So the point here is that if you want to use a property package from as a PME from multiple threads, you do not only need to adhere to the threading model. There's a bigger picture. There's a whole sequence that takes part on the interaction that maintains state. And if you want to reuse it, you need to really make sure as a PME that you wait until one part that depends on a particular state is done before you impose a new state on the property package. So in COBIA, we actually went a little bit further. We said if the PME must synchronize around such big chunks of data in any case, then we may as well require that COBIA is not allowed to make concurrent calls on the property package or any other PMC for that matter, because it makes life on the programming side of the PMC a lot simpler. On the PMC, you don't have to be concerned with data races and whatnot. So all the synchronization requirements are placed by COBIA on the PME end. This is different from what happens in COM. First of all, in COM, if you choose a threading model, you choose the threading model for the current thread. You cannot make a threading model decision per PMC, which is how we designed it in COBIA. So if you have two PMCs that you're talking to in one thread, you can choose for one PMC, I'm going to reuse this PMC from other threads. So set this PMC up with a more lenient threading model, but this particular PMC I'm only going to use within this particular thread. So set it up with a very restrictive threading model. So we came to the conclusion that the following threading models per PMC would be convenient choice for COBIA. The default threading model is the PME can use the PMC from any thread, as long as you don't make concurrent calls on the PMC, which puts all the responsibility for synchronization on the PME end. But the PME needed to do that synchronization in any case to get around these blocks of dependency. So if a PMC cannot do that, a PMC can say, I am not capable of doing that. Please write me down for restricted threading. And restricted threading means that the PME is only allowed to access the PMC within the thread that it was created from. In that scenario, there's never any chance of any multi-threading issues to appear on the PMC side, because it will only be seen from one thread. Which is not the same, by the way, as single-threaded. COM also features a single-threaded model, but then everything goes over the thread. And here the single threading is really restricted to one PMC. You can, however, have two PMCs, each of which live in their own thread. So if you're a PMC author, you still need to, even in that threading model, take into account some possibility of shared resources being accessed from multiple threads. The PME can, of course, say to COBIA, I know that I'm going to use this PMC only from this particular thread. If that is the case, COBIA will not sit in between if the PMC is not capable of doing anything more than that, which is a different scenario than the PME saying nothing at all, in which case the default threading model applies, and that says the PME is allowed to reuse that PMC from different threads. If the PMC then says, I cannot do that, then COBIA says, need to do something about that, need to sit in between. I'm going to run this PMC on a separate thread and only access it from that thread as per the threading regulations for that particular PMC, which is called marshalling. So that has to also interact with COM. What you see here is the decision tree when COBIA is creating a COM PMC, which is the complicated scenario. The opposite scenario is actually very easy. When COM is creating a COBIA PMC, the COBIA threading model applies per PMC. So we can simply advertise the PMC as something that can deal with multi-threaded, which matches more or less our default threading model, or it cannot deal with multi-threaded, which is our restricted threading model, in which case it will be in COM terms apart from threaded. So that's the easy way. The opposite way around, if we want to use a COM PMC from COBIA, we need to make some arrangements because the COM PMC threading models apply to an entire thread, and we need to make some decisions on what thread to create that COM object in. And I'm not expecting you to read this diagram, The only thing I wanted to point out in this diagram is that there's not a single route in which the COM PMC will be directly created from a COBIA PME unless the COM PME also initializes COM. Unless the COBIA PME is also initializing COM. COBIA will not initialize COM for you. So that is my important note to developers on the new COBIA and therefore the threading models that we're releasing. From a PMC development point of view, it is all very simple. Just go with the default threading model if that is possible. And then you really don't have to do anything else because COBIA will take care of everything for you, including proper advertisement to come. If you're a PME developer, you have to take into account two things. If you're going to use a PMC from one particular thread only, then tell COBIA so, because that might prevent your PMC from getting marshaled. The other thing is, if you're on Windows, initialize COM for a threading model that is appropriate for your application, which is of course a bit of a pity, because if you're programming COBIA, we would like you to have to not even think about COM, but that's the way it is. We can in COBIA not get around that. Your only task as a PME developer on Windows is properly initialize COM to prevent marshalling of COM objects. So much in the threading. Let's have a look at the bigger picture. CAPE-OPEN interfaces are defined in an interface definition language document, an IDL file. So you define your interface with your methods, your arguments in a text file, and this text file gets compiled by the COBIA code generator. And from that, you can generate CPP code, for example, or any other programming code for that matter, that defines the basic object that you're going to implement. For example, a material object on the PME side or a unit operation on the PMC side. And that code is then compiled by your favorite compiler into something that will actually run, so binary code, either an executable or a DLL. That's the task of the compiler. So we start from type information, then we use the COBIA code generator to make programming code. The programming code, you have to add the little bits that do the actual functionality. You compile that, you have a binary. That IDL, however, must be, from a marshalling point of view, consistent with the COM IDL. If we want to be able to marshal COM to COBIA and COBIA to COM, the two must be 100% consistent. And the route we have chosen is, you write the COBIA IDL, and then from that, from code generation, we make the COM IDL. And then the COM IDL can be compiled by the Microsoft IDL compiler to a type library on Windows. The type library can be used by any COM wizard in your favorite integrated development environment into a code project, and eventually you'll end up also with a binary, a DLL or an executable. But that's then of course a COM binary. This is not the only bit that you can do with the type information. Maybe you remember the marshalling presentation from last year. I've also hinted to it earlier. We need proxy objects that take an incoming call, make the arguments to something serializable. That is on the client side, and on the server side, we need the opposite, proxy objects that take that serialized information and make an outgoing call on an interface method. These proxy objects can be pre-compiled. For that, we also have the COBIA code generator. So you take the type information. We generate code that makes these proxy provider DLLs. We compile a proxy provider DLL from it. And these DLLs you can install with your software. And then you tell COBIA at installation time, I've got a proxy DLL for that particular type library that lives in that and that location. And once COBIA needs to marshal or anything that requires a proxy for that matter, it just creates that DLL and takes the proxies from there. This is in fact actually what the new COBIA installer is doing for the CAPE-OPEN types itself. It has the proxy types for all the CAPE-OPEN types on board, and it will install that for you on your system when you install COBIA. But that is if we pre-compile the proxies, and that means we need to know the types at runtime, and quite often we don't. For example, because they're not our types. They came from some third-party software vendor that made their types and their custom types. At that point, we need to create on-the-fly proxies, and the on-the-fly proxies work by making an in-memory binary object that receive a call or make a call, and that of course requires also the type information. So the type information goes into the registry. The COBIA type information goes directly into the COBIA registry using COBIA tool. And then we can do on-the-fly proxies from there. And the same thing actually happens for COM. COM also needs the types for marshalling for exactly the same reason. It needs to map the memory properly at runtime. So COM provides tools for doing that from a type library. You put the type library in the COM registry, and then COM can do the marshalling for you. So this looks like a complicated picture, but this is all there. This is essentially the core of COBIA 3. This all works. This has been tested. And this is what we think should be the future of interoperability for CAPE-OPEN. You start with the COBIA IDL, and from the COBIA IDL, you go the whole route of COM, code generation, everything. This is the big picture. This is the picture I want you to take away from this particular presentation. We actually want to go a step further, because why stop there? We're writing CAPE-OPEN specification documents in which we write down what a particular interface does, why it is defined, how you should use it. And in that particular document, we already define what the interface looks like, what the functions look like, which arguments there are, and we have documentation at that point. We really would like to have that to be the actual source of the CAPE-OPEN interface specification, from which we use a particular renderer to render the COBIA IDL. And if we do that, as I mentioned, we also have the documentation already of the interfaces, the methods, and all the arguments on board. We can then put from our code generator all of those comments directly. This interface is implemented by unit operations and serves for the purpose of, etc. We can put that in the IDL itself. And if the documentation is in the IDL itself, we can use our own code generators again to put that same documentation directly in the source code. And then you can use any third-party documentation tool of your liking, for example, AmsterCHEM, to generate your source code documentation. And all the essential CAPE-OPEN stuff will be in there without you having to do anything for that. And that, I think, is a big win if we can get to this picture. And I'm actually intruding on Kyle's presentation here, because Kyle's doing a whole presentation on this. If we do that in any case, then of course, we can also render consistent information with the same documentation as we find in our source code, and the same descriptions of the same interface methods, etc., and generate the actual specification documents from that in PDF or in web form. And we're currently working a lot on test specifications that Malcolm and all the SIG presentations will elaborate on. And it's the same story there. We want that to be consistent with the documentation. So common source CAPE-OPEN specification document is on my wish list, and it is on the wish list of some other people in this room as well. We're going to be working on designing that strategy, but that's future music. This is not yet there. We can, however, start by, of course, by making room for all the documentation bits in the CAPE-OPEN IDL, which we currently don't have, but that's not too difficult to do, which is one of the good things about COBIA. It is our IDL, it is our tools. We have control over what it can and cannot do. Okay, so to continue with the COM interrupt, the current situation has been this. We have inherited COM IDL from the last 3 decades or so. And the COM IDL is necessarily inconsistent with the COBIA IDL because it has accumulated over time. We have several different integer types. We use weakly typed variant structures for carrying data, etc. So if you are creating a COBIA object from a COM object, which was possible since 2016 already, that was one of the first pieces we had in place. There's currently a bit of code in the COM to COBIA translation layer, which we call COBIA, which has a specific implementation of iCape identification, for example, and iCape unit, both of which you would find implemented on the unit operation object, that take an incoming COM call, translate the COM arguments to COBIA arguments, and make the outgoing COBIA call. This is from the COM to COBIA side. If you call a COM object from the COBIA end, the situation is exactly equal, but you have to reverse the direction of the arrows. Still, you have the yellow block. So for every interface that we implement, we have 2 specifically coded conversion blocks in the direction from COM to COBIA and COBIA to COM to maintain for every interface that we publish. And that is just the interfaces that we know about at compilation time. If there's a custom interface that we don't know about yet, we can't do this. We can't pre-code predefined conversion blocks. But that is fortunately, hopefully, past tense, because now we have any other interface for which the COM and the COBIA definitions are necessarily consistent, because we have generated the COM definitions from the COBIA definitions, and we have type information for those. So now we go back to the notion of we have a client proxy on the command, which takes an incoming COM call and translates it to something serializable. And we have a COBIA proxy on the COBIA, a host proxy in this case, which takes that serialized information and makes the outgoing call to the COBIA side. And now the only piece of software that we need to maintain is here, the conversion of COM arguments to COBIA arguments. And as you guessed it, these COBIA proxies are in any case the same proxies that we use for marshalling. So that machinery we have already had in place for quite some time, and that actually lives in our marshalling DLL. So doing everything in a consistent manner gives us essentially the freedom to marshal any interface for which we have type information, whether it's at compile time or at runtime, in a manner that doesn't require us to have all of this overhead for implementing specific translators for every interface in the long run. This, again, is all in place. This works. This has been tested. We have test code that implements custom interfaces, some of which are pre-compiled, some of which are on the fly, with a test PME and a test PMC, both of them in COM version and in COBIA version. We run 200 tests just to test this machinery, and it all works. That, of course, means that we need to make some concessions to make the COM IDL consistent with the COBIA IDL. That means that the COM IDL looks a little bit different than you're used to. First of all, we are getting rid of iDispatch. All of our COM interfaces were dual interfaces. That means you can use them for early binding when you have to type information at compile time, and late binding when you can make calls just by name at runtime. Late binding is actually not used by anybody, and the implementation that was there for late binding in CAPE-OPEN has been broken from day one, which I pointed out already in 2014. And we're finally at the point where we're saying no more iDispatch, which means we derive everything from IUnknown, which is a simpler interface. We still want the default COM marshallers to be able to do the marshalling, because we do not want to reinvent COM marshalling. That means that those COM marshallers want us to annotate the interfaces with OLA automation compatible, automation compatible. So you will find that annotations in the generated COM IDL. That means that all the types we use there must be compatible with OLE automation. In particular, there is no UUID in that particular set of arguments that the default marshaller will do for you. We're marshalling UUIDs as a string, as a concession, but this is a very small concession. The other thing is that, strange enough, there is no definition for the size of an enumeration in COM IDL. It is platform independent, and I could not even find a definition on what size they are on the 64-bit platform. So if we want to marshal from COBIA to COM and from COM to COBIA, we of course need to know how big the integer is. Otherwise, we can't convert that bit of memory space. Fortunately, COM has this v1_enum annotation, which makes all the enumerations 32-bit in size, which incidentally is also the size we use in COBIA. So if you find COM IDL with this weird annotation, you know why it is. It is because COM doesn't really define what the enumeration should look like otherwise. Okay, that was it for the COM interrupt. The big message there, of course, is COM interrupt is there to stay. It's not going to go away. It's just that we want to really change the workflow by starting from one consistent point, which should be the COBIA definition, and we'll work our way to COM from there. And all the machinery to do that we have in place. It's all there. Then COBIA makes some more promises. The first promise is language bindings. The C++ language binding has been there from day one, which is of course an obvious choice. This is also how COM started. C++ is an object-oriented language, and COM and COBIA define interfaces it is almost as C++ is defined around COM rather than the other way around. Well, the two came hand in hand, in fact, but that's a long time ago. So C++ was already there. What we added was an ISO-C definition. Until now, you could not import the COBIA header files in a C program because the C compiler would simply not understand those C++ constructs that we were using. Now it is possible. And that also opens the way for some other interoperabilities, some other language binding scenarios. One that I'm personally working on is binding with Rust, which is one of these new memory safe languages. And I think there's a lot of synergy between Rust and CAPE-OPEN interfaces, because in CAPE-OPEN we make a lot of contractual agreements. The PME should do that, the PMC should do this, but we really have no way to enforce it in C because C is flexible. We can say, of course, this particular argument is an input argument and you may not write to it, but we cannot prevent people from doing it, which is not the case in Rust. In Rust, you can make the compiler simply say, can't do that, this is an error. So I like going that way, but first of all, I didn't get it done. I was short on time to get it done before this conference. And second of all, I don't have enough time to present about it. So I'm going to promise you next year in October somewhere, I'll be presenting about Rust language binding to COBIA. And that will then be the first language binding, because the management board has said 2-3 years ago, before we implement any language binding, we really want to know if we're not wasting our time and energy on nothing, and we need some kind of commitment from software vendors that they will actually implement such a language binding. We need a use case, says the management board. So fair enough. We're waiting for use cases for example, 490 language binding. .NET is a story by itself. .NET, or previously .NET Core, is the follow-up of .NET Framework, and .NET Framework is essentially what we're all currently still using on Windows. .NET runs on Linux, .NET Framework does not. The way to call native code from .NET is actually rather straightforward. There's something called pinvoke, you can make those calls rather directly. But calling .NET code from native code is a lot more involved. Not on Windows, because on Windows the way to do that is you use COM. .NET implementations can all expose themselves as COM, and that is the way to instantiate a .NET object from a native environment. We can't use that on Linux, of course, because on Linux you don't have COM. So this is something we still need to work out on how to design that, and before we can do that, we need somebody to commit to, yes, we're going to implement against your .NET language binding for COBIA before we go there. To me, it's a very interesting platform. Implement something in .NET, run it across the whole board, Linux, Windows, macOS. I think that's a very nice thing to have. The other language bindings that there is interest in is Python, Java, etc. Same story holds. I'm not sure where we lost a couple of points on this slide, but we need a business case. Oh, it says I moved it up. It says it right in the main bullet there. So if you're a software developer and you are interested in COBIA language bindings, by all means, speak up. The next thing that we promise in COBIA Phase 3 is that it will run on multiple platforms. It has been running on Windows all along. This is the main platform, of course. I cut my complete science in half for the lack of a better graphical representation. We have been running on Linux as well since day one, because you do not design something that is targeted for multiple operating systems and not check if it doesn't cross-compile on Linux. So Linux was there all along, and if you have access to the source code, you can simply compile it and run it on Linux. But we need to distribute on Linux, because the purpose of CAPE-OPEN is that you run multiple pieces of software from multiple software vendors on the same computer, and if each of them bring their own flavor of CAPE-OPEN, it's probably not going to work. So the consensus is CAPE-OPEN is freely distributable, but we would very much like you to use the binaries that are provided by CO-Lan. Thank you very much for not breaking things. So then clearly we need to provide the binaries on Linux. We tend to think that we've got most Linux distributions covered if we only provide a Debian package and a Red Hat Package Manager package, there are some other distributions that do not fall in that, but if there's a business case, we're quite willing to go there, because installing a Linux virtual machine on your Windows virtual machine to do the compilation is very easy these days. There's one other issue that we need to sort out, and that is the edit method takes as input argument a window ID of the parent window, and on Windows this is all very well defined. It's an Edge window. On Linux, we're currently presuming that we're going to be dealing either with old-fashioned X11 windows, which have a string descriptor, I think, or with the new Wayland Windows descriptors, and we need to do a little bit of sorting out there before we can make formal definitions on what a window ID actually is on Linux. And then, of course, we need to distribute it. I hope we get to that this year. The story on Mac is quite the same at the state as we are now, but it's quite different in the fact that we only did this year. This year, COBIA doesn't only compile on Intel Mac platforms, but also on Mac Silicon Mac platforms. Fantastic, it runs. Same story, window ID needs to be sorted. On Mac, you have the Cocoa windowing system, for which we need to somehow figure out how to represent that as a formal item. And we need to distribute that. And the way to distribute that on Mac, you distribute applications essentially as a big zip file, which is called a bundle, which is code signed. So COLAN needs to get another code signature for macOS. And this particular type of bundle would be a framework bundle, because that is the type of bundle that multiple applications compile against. So hopefully we also get this done this year. I didn't put it on the slide because I don't think I can make that promise. Transport was also there from the very start. I've demonstrated that as well. I've had a little application running on Linux with a little PME running on Windows, and the two were interoperating. But TCP/IP, of course, is particularly unsafe. If you don't have to sit in the middle and eavesdrop on the traffic, and you can see what is going on there. So you should really only be using that if you're in a secure environment behind your own firewall, away from a public network, which is something we should surely change. My take on it is that we should use secure shell for the transport, because it comes pre-installed on Mac, Linux, and Windows, and it provides us with all the necessary authorization setup that we need. The story there is, again, we need a business case. We need somebody to say we need a remotely operated CAPE-OPEN PMC or PME for the management board to commit time and effort to it. Then finally, logging. Logging is part of COBIA Phase 3. The logging story is actually surprisingly similar to the marshalling story. If you would take a client and a PMC and they interact with each other, really all you need to do is sit in between with the proxies for which we have the entire machinery, and serialize it to something that is transferable over any pipeline. Not put it over a pipeline, just put it in the next proxy, but also feed it to a logger. And we have quite some experience logging on COM. We have the CAPE-OPEN logging and testing tool for COM, and Coco ships out oats coolies that does the same. But there we have specific implementations, very much along the lines of what I showed for COBIA interop, for specific interfaces that expect specific calls, and log those specific calls with their arguments to an XML file. We can do better in two aspects. First of all, we have type information. We don't need to do any specific logger. All we need to do is sit at the transport along with the type information and serialize it in some generic way. Any interface we can log then, even if we did not know about the interface at compilation time. And the second thing we can do better is, yes, of course, we will provide a logger that will write XML, but it doesn't have to be your only purpose of logging. Perhaps you want to write an application that makes all the CAPE-OPEN calls scroll over your screen while they're happening, or perhaps you just want to call how often people are changing the name of a particular object, or perhaps you're interested in writing an application that helps you debugging, that allows you to set a breakpoint at one particular CAPE-OPEN function call. So the ideal thing, of course, is that we're making a middleware, so we can take the actual information that's being logged also in an interface, which we will then call COBIA logsync. We will provide a default implementation that will make an XML file, but you're free to change that implementation and make it whatever you want to. So that's the story on logging. It is not there yet. It will be there this year. The proposal is on the table on how to do it. We know where to go. Most of the pieces are already in place because most of the pieces are reusable from our marshalling library in any case. So that concludes the story on features on COBIA. So I'm going to have some closing remarks. The main story here is that we are moving away from COBIA phase 2 that has been in production for a while, and we're moving to phase 3, which contains essentially all the core functionality that we have aimed for from the beginning. It is, from a production point of view, pretty much feature complete. What we're missing is some of the periphery, some of the implementation details, such as language bindings, distributions, etc. But the core is complete, it's there. We have released a beta at the beginning of this month. This beta has already been tested at some companies and it works. So I'm expecting that early November we have COBIA 1.2.1.2 out, which is then the first full release of the COBIA phase 3 project. It is ready for production. It is, in my opinion, allowing us to set up the infrastructure to go to a new CAPE-OPEN version where COM and COBIA come together, and we have one consistent way of documenting, generating IDL, generating COM IDL, making it all tied together at runtime. I think that this is the glue to do it all, to go to different platforms, etc. The big message also here is COM interop will remain, and even though the interfaces on COM will look slightly different, the functions do not. Functions look exactly the same, which means that if you have a COM implementation and you want to go to a COBIA implementation, so you want to go to a new version COM implementation, you can essentially reuse your functions. And the work to get there is therefore very minimal. You will need to implement new interfaces, but interfaces are essentially just a bunch of pointers to functions. So the actual implementation work is very small. COBIA is, of course, free to use as long as you use the CO-Lan distribution for the binary part. If you want to have access to the source, you should be a CO-Lan member, then you can access the repo and download COBIA and debug it and play with it. The documentation is not there yet, it's very sparse. It will come. We're going to work on that over the next couple of years. There is a reasonable how-to in the Visual Studio wizard that I'm providing. It contains a PDF document with a step-by-step how to use the COBIA code generation and go to unit operation. That does not mean that you're dependent on third-party projects such as the COBIA Visual Studio wizard, which is free but still third-party. Because all that wizard is really doing is it's calling the COBIA code generator under the hood. So if you don't mind typing the commands on the command line, you can do exactly the same with the COBIA tools that are there. And that is really all I had to say today.
Jasper, presentation is open for questions. Yes.
If COM is still supported, can it be out of process? Or,
yes, and COBIA as well.
It can still be out of process.
Yes.
So only the COBIA interface and the next layer are in process then.
Well, COBIA you can also do out of process. We have all the transport and marshalling set up in COBIA, so you can make a COBIA PMC that runs in an executable and create it from another executable. COBIA can also be remote. So it doesn't.
You said very early that it has to be in process.
That was phase 2. We're now moving to phase 3. We have everything in place.
But now have the CAPE-OPEN unit operation implemented, and now you say you want to move to COBIA. You say that it's easily integratable, so we can
that bit of work you have to redo. What I said was that is very little work compared to actually making the functionality to make your PMC in the first place. So whether you're programming against COBIA, you still have to have a function that validates your unit operation, and you still have to have a function that calculates your unit operation, and that's where the real work is. The real work isn't in calling those functions from one to the other. So switching interfaces in the case is very minor work.
What do you think? When is this standard with COBIA will start? Did it already start, or so? What is the time frame somehow?
It started in 2016 when we released phase 2. We're releasing phase 3, hopefully, well, next week. Okay, next week.
Okay. Oh,
That's the time frame. Documentation is not there. Linux distribution is not there. Hopefully this year. Logging is not there. But if you go back to the slides online, you'll see that most of the slides have this little complete icon in them. That serves as a reference.
Any further question online? Yes.
Hi Jasper, it's Dave Gibbons here. So we have had our XFH Ultra tool released for just over 3 years now. It's been working fantastically well. Your title of your presentation is saying COBIA is ready for full production. Is that really referring to the phases that you're now adding, or are we missing out on something significant with XFH Ultra?
No, because your XFH Ultra runs in process on Windows, so you're exactly falling within the limitations that we have in phase 2. What I'm saying now is that those limitations aren't there anymore. But so if you want to now make your software run on Linux, you can. But you have some other issues there because if I'm not mistaken, some of the parts of your application are in .NET. But we also had a discussion that you move to .NET Core or .NET Nut Framework, or for lack of a better name. But you're still tied into WinForms, I think, right?
Yeah, I mean, we have lots of limitations, not least of which is that the software that we primarily interact with are process simulators. And I'm not sure that any of those, perhaps with the exception of your own, would run on Linux anyway. So we're kind of tied to Windows anyway. So I'm just intrigued to know what we're missing out on.
Not yet, actually, for Coco. I'm still, unfortunately, also on Windows bound. There will be a lot of work in going to Linux, but it's definitely on my planning, yes. And I don't think I'm the only one. Most of the cores of the process simulators are in any case in Fortran. You can compile that anywhere. It's the front ends that are the problem typically. So even if people would assemble the flowsheet document on a Windows machine with the Windows front end, you can still essentially run it on your favorite cloud platform on Linux. I see us going there soon. Everybody, including the platforms that your software is running against.
Okay. Thanks.
Sergey, online, I believe you've got a question as well.
Okay. Jasper, good morning. Thank you for a very impressive presentation. I have a question regarding parallelization. We are interested at the moment. We are using COM, and as I understand, currently we are able to call the property package using CAPE-OPEN only from the thread where the property package was created. What changed with the COBIA with this concern? And you have mentioned that interoperability is not stateless. For me, it's not really so, because actually full information about the material state is there in the material object, and presuming that the property package could be itself stateless, one could perform parallel evaluation of thermodynamic properties on the same property package. So what changes with COBIA? Could you please explain it a little bit more?
Well, there's actually many questions in there. For the reason you can only access your property package from one thread at the moment is presumably because we have all grown used to using the apartment threaded model on COM. So you're talking to a property package implementation that is no doubt apartment threaded. So even if you would create your application in such a manner that you initialize COM in a multi-threaded manner, COM is going to say your property package cannot deal with that. I'm going to put it in a separate thread, and you'd be worse off because not only would it still run on one thread, also it would run on a different thread than you're calling it from. So when we designed the initial couple of iterations of what we should do with threading in COBIA, we were very much inclined to kind of stick to that same paradigm because that is where all the current implementations are, and it will take some time to move away from that and go to a place where PMCs are reusable from different threads, and you can essentially build a pool of PMCs that you use in the threads that you need them, rather than on a 32 thread process having to necessarily create 32 instances of your PMC, which is where we currently are. It was actually Mark Steinman that said, why would you do that? Why would you take all the baggage that we have from the past and take it into a design that needs to serve us well in the future? So we decided, Mark, you know what, you're right. We're going to do it different in COBIA. We're going to make COBIA more flexible. We're going to do the best job we can on COM interrupt, because actually if you start writing now in COBIA, you don't have that default restriction of apartment threaded. We have changed the way we do the COM registration. If you would now write in COBIA, your COM registration of your PMC will be both, which means that whatever the PME does, it will work in thread. We have put out a threading advisory last year that essentially states the same. It also points out a couple of shortcomings in PMCs that are out there. There's quite a few PMEs that are out there. There's quite a few PMEs that actually create the PMCs from the main thread so that you can configure them from there. And the main thread is typically a single threaded thread. And then they reuse these PMCs from calculation threads that run in the background to keep the windowing responsive. But what happens then, of course, is that COM says, no, you can't do that. These PMCs are apartment threaded. You need to keep them on the same thread. And it's going to, from the calculation thread, marshal these calls out to the main thread. They still interfere with your windowing, and they're all being performed not only on one single thread, but also on the windowing thread, which you want to keep free. So thinking about threading becomes more and more important, not only in COBIA, but also in the existing COM implementations. This does not take away the state part. So from a PME point of view, you're going to have to think about the state in any case, until we're at the point where we're saying we're going to pass the material object as an argument to the call itself and take the state away from that. Because you're right, most of the state lives on the material object, but which material object that is still state on the property package. And this is something that we can probably fairly simply design for the property package, but for the unit operation, it is a bit of a more unpleasant thing to make stateless. You have to pass to each call all the streams that are connected to each of the ports. You have to pass the entire set of parameters, etc. It's not so easy to make a unit operation stateless. So the general concept still holds. What has changed? Our way of thinking about it.
Okay, but I think that the point parallel evaluation of thermodynamic properties is perhaps the most important business case. I agree that it would be much more difficult to realize the parallelization for units, but I think in focus we should keep in focus thermodynamic here, and in this case, passing material object as an argument to the property package would really solve the problem.
It is not the only way to solve the problem. The reason that it is expensive to create multiple copies of a property package to begin with is that 60–70% of what you have in your memory is actually static, and you want to share that between different instances. And then for each instance, you have a bunch of information that you want to cache in any case, such as during a flash calculation, the entire matrix of interaction coefficients evaluated at the proper temperature. So one workaround that we were thinking about is actually to allow a property package to spawn a second copy without going through persistence from the same instance that's already in memory. And that instance can then be used from a different thread and would have its own material context and whatnot. So you end up with two copies of the property package that have been created from the same underlying instance. So they would appear as two separate objects, but they're really only two facades for the same property package, each of which can be accessed in a per thread manner. And then you have resolved all these issues as well, specifically for thermal.
Okay, thank you.
Thanks for all the questions, everyone. We now have about a 30-minute break, and we'll pick up after the break with the next presentation.